Hello and welcome to helpyourmath.com. In this video, we are going to look at planning ahead with a savings plan. In previous examples, we knew how much we wanted to deposit each month, and then we figured out how much money would be in that account after a certain amount of time. But what if we have an end goal in mind and we want to make deposits based on that? That's what we're going to talk about in this video. Here's the example that we're going to focus on. You want to build a $100,000 college fund in 18 years by making regular end-of-month deposits. We are going to make the assumption that the APR for these 18 years will be 3%. We want to calculate how much we need to deposit monthly. Once we do that, how much of that final value comes from the actual deposits and how much comes from the interest. You see the formula I've posted here is very intense. We definitely will want to use a calculator, so if you don't have a calculator, please go get one now. It's really important that you do these calculations with me so that you know how to get these numbers, because sometimes you can watch someone else do it, but when you actually have to sit down and do it, you might make mistakes, and we want to make sure that we're finding the mistakes while we're doing it together versus when you're doing this on a test and all of a sudden your answer is incomprehensible in the calculator or so tiny that it doesn't make any sense. Okay. First thing we're going to do now that we have our calculator is we're going to define what we know. So we know that that end amount, we know that at the end, we would like for there to be $100,000 in this account. This is what we don't know. So this is what we're trying to figure out. So hopefully we know a value for every other variable. The APR that we're assuming we're going to have is 3%, which I like writing as its equivalent decimal, which would be 0.03. The lowercase n, it said monthly deposits, that would be 12 in a year. And the number of years in this case was given as 18. And is that everything? I think that's all the variables. So now what we're going to do is we're going to plug in, we're going to clean up that big fraction, and we're going to see what happens with that regular monthly payment. So we have 100,000 is equal to our unknown times, and then we have 1 plus 0.03 divided by 12. And one thing I like to do before I get started on plugging in, and I forgot to do it, so we're going to do it now, is I'm going to create a variable. I'm going to define this n times y. So many mistakes happen if you don't do this, so I just say get it out of the way, do it before you plug it into the formula. So before we even do that, we're going to say n times y is 12 times 18, which is equal to 216. And then I know that this is going to be to the 216th power. We're going to avoid mistakes by doing that. And all of this is divided by, remember we kind of repeat what we have in the parentheses, 0.03 divided by 12. We want to do this one step at a time using order of operations. We already took care of the first thing, which was this raised to the n times y. We took care of that. Now we want to work inside the parentheses. We see division. 0.03 divided by 12, this will become 0.0025. I just want to clean it up step by step because I know I'm going to run out of room. So I'm going to do the best I can to try to limit the number of times I rewrite this. PMT times, so this becomes 1 plus 0.0025. So we have 1.0025 raised to the 216th power minus 1, and this is all in the numerator, over, and remember what this is equal to? We just did it. It's 0.0025. When we raise 1.0025 to the 216th power, we end up with a crazy number. It ends up being about 1.71485, blah, blah, blah. So this here becomes something like 1.714, we'll say 9 because there's an 8 followed by 5. Then we subtract 1 from that, right? Because that's in the numerator too. So this whole thing became that. Subtract 1 is going to just get rid of that 1 there. So we have PMT times 0.7149 divided by 0.0025. Okay, so now we have 100,000 is equal to PMT, and this thing, when we divide, we end up with 285.9403. 285.94 0.03. And you might be saying, wow, that's kind of like a nice monthly payment, isn't it? We're not done yet. This is just being multiplied by that unknown monthly payment. We have one step left before the mystery is revealed as to how much we need to deposit each month. We need to divide both sides by this random weird decimal. And when we do this, I'm rounding just arbitrarily to apparently to the 10,000th place. If you're cutting it off sooner or if you're using exact numbers, these numbers are going to vary slightly, and that's okay. We're looking for a ballpark. We don't need it to be like to the exact penny. Okay, so those cancel. And when we divide here, I ended up getting 349.7232. But the way that I viewed this is that we should bump it up so that way you have 100,000 in the account. If you round it down, you're going to end up with just slightly less. Again, this is my own personal opinion, and the textbook disagrees with me. They round down because that's what we should do because the 3 is followed by a 2. But my personal belief is that it should be above 100,000. So I'm going to round it up. And again, this 1 penny is not going to make or break anything. Nobody should get this wrong because of this one single penny. So that monthly deposit should be, in my book, $349.73, but in the textbook it says 72 cents. Okay, we did it. Yay! So the monthly payment we need to make is about $350 a month. The next part of the question says, well, how much of this final value comes from the actual deposits and how much comes from the interest? One of those is going to be much, much easier to calculate than the other, and that's going to be the deposits. So to answer this question, we're going to look at the deposits and then we can use our knowledge to kind of figure out an approximation of the interest because we don't need to know it to the exact penny. This is going to be just fine. So we know that we're paying $349.73 each month. So we're going to say in 1 month. Then we're going to multiply this. There are 12 months in 1 year, and we are doing this deposit for 18 years. So this years cancel, months cancel, there's that dollars. And when we do this calculation, 349.73 times 12 times 18, we end up with 75,541.68. So we're just going to approximate here. This is $75,000 approximately for that total $100,000. So it looks like this is about 3/4 is coming from our actual money, and 1/4 is coming from the interest. So 75% is coming from the deposits, those monthly payments, and 25% is coming from the interest. This has been an example of planning ahead, looking at when we know an end goal and kind of building the monthly deposits around that. Thank you for stopping by.